Okay, here we are one more time. We're back into our environment, and let's go ahead and start with ladder. We want to begin in as familiar territory as possible. So I'm going to double click on my program 2 that I've got over there. Yours might be a different program. Just go for the one that's got the ladder icon next to it. And then this thing pops up and, it's ladder logic, but you look at it and you say, man, this doesn't look like anything I'm used to. That's okay. We're going to make it look familiar real quick. So right away we say, okay, we need tools. We need some instructions to bring in here. Come over here on the right and click on this toolbox. And there you go. Instead of having a whole bunch of different tabs that you have to go through to find everything, these are all of your ladder objects, everything that we're going to be able to work with right here. So, wow, you're thinking, man, that's not much. But don't worry, there's some hidden stuff in here. So there's actually quite a bit, probably way more than you'll ever need, but it's going to get the job done and then some. Let's go ahead and start looking at some of what we've got. We've got jumps, we've got returns, we've got branches, and all of these should start to sound familiar to you. We've got what's called a direct coil over here, and think of that as being an OTE, or an output energize, or a relay. Then we've got reverse coils. So instead of energizing something, we're de-energizing something. We've got set coil and reset coil. So when you hear those, think about your OTL and your OTU. We're going to touch it once to make it come on and stay on, and then we're going to touch the reset once to de-energize it. Look right here, we've got pulse rising edge coil and pulse falling edge coil. I mean, what are they trying to say with that? Well, that's our one-shot rising, our OSR, and our one-shot falling, OSF. So when you decide you need a one-shot, this is what you need to be working with. And then we have direct contact and reverse contact. Okay, we've got coils up here and we've got contacts down here. Think about relays. They're thinking about relays very heavily when they're naming this stuff. So that's why we're talking about two different parts of a relay. We're talking about the magnetic coil that you energize to close the contact. And then over here we're thinking about the contacts opening and closing. But in programmer language, because we're programmers, not electricians, most of us, these two coils represent our OTE, and this is kind of like a reverse OTE. And these right here are going to be your XIOs and your XICs. So direct contact would be XIC, examine if closed. Reverse contact would be XIO, examine if it's open. And then we have pulse rising edge contact and pulse falling edge contact. So think about these as basically contacts, or an XIO or XIC specifically for one pulse only. So instead of having to create a one-shot to send a pulse, you can just use this type of contact, which is only going to detect the first pulse or the last pulse. Kind of a strange paradigm, definitely it's a different way of thinking about ladders, and that's not even where the differences end, but that should at least familiarize you with the basics. And just with that alone, you can get this project done. But don't worry, there's a lot more. Check this out right here, this instruction block. What on earth is an instruction block? Well, that is what I'm going to show you now, and this is pretty cool. So I'm going to go ahead and click on that and drag that over here to this plus sign and let go. And as soon as I do, you can see I've got a little square that kind of appeared in the background. And in front, look at this. Here's where all those missing controls are. We've got PIDs, we've got scales. Right here, it's called a scaler. And things are named maybe a little bit differently in here, so you might actually have to read through these comments to see what some of these things do, but we've got all kinds of different stuff that we can work with in here. So coming up here, let's say we wanted something as simple as a move. Well, I would just go ahead and click on that move and hit OK, and all of a sudden this turns into a move block. And now you're looking and saying, well, it's a move block and that's an action, but why didn't it go over on the right? Well, here's the funny thing. You can actually have something off to the right of your move. In fact, as long as you don't have a jump, a return, or a coil, then you can have something else to the right of it. So I could have this move here, I could have a timer to the right of it, and then I could have, something else even after that. But as long as I don't have anything to the right of a coil, of a jump, or of a return, then I'm fine, and my program will compile. So, that's kind of weird, right? You can have multiple actions on the same ladder. But it kind of makes sense, because check this out. Let's say I double click on rung and I add another rung down here. And now I say, you know what? I want a timer that's going to energize a coil. Well, it used to be you would have to create the timer on one line and then use the done bit on a different line to energize the coil. And usually that timer is just going to be for that coil. So, having them on two different lines is kind of a bummer, because at that point you're like, well, these two are directly related and I would love to have them on the same line to make my logic that much more readable. But, I can't do it. I really have to put them, at very least, I have to put them on separate branches, but more likely I'm going to have to actually put them on different rungs altogether. Well, check this out. I've got my TON right here, and that's our favorite timer. And then, let's say whatever it wants to energize, I'm going to put a direct coil, and I'm going to set that right there. And now a variable selector pops up, and what do I want this thing to be, energizing? Well, I'll just say it's going to turn on our classic example of a pump. And I'll go ahead and hit OK. So now we've got a pump that's going to be energized. What is this Q inside of our timer? Well, Q is basically your done bit. So instead of DN, now we're working with Q. And N, this is what's actually an input signal into our timer, which is allowing it to start working. And then we have PT and ET. PT, if you just hover over this, it's going to tell you what everything is. But PT is your preset time, and then ET is your elapsed time. So what kind of timer can I do here? Well, let's say I want a timer that is 1 hour, 30 minutes, 15 seconds, and 7 milliseconds. Well, you know what? I can actually create that kind of time in this environment. So check this out. To define time, I need to start with a capital T and then a pound sign. And that's going to indicate that what's coming after it is actually a time value. And I said I wanted 1 hour, so I'm going to type 1H. Then I said 30 minutes, so I'm going to type 30M. I said 15 seconds, so 15S. And then I said 7 milliseconds, so 7ms. And just like that, I have created time. And when I hover over it, you can see it says type time. So, wow. I mean, now imagine going back to RS Logix 5000 and trying to set up a 1 hour, 30 second, 15 minute, and 7 millisecond timer. You're not going to be able to do it without whipping out your calculator, not unless you're Rain Man or something like that. Let's assume you're not, and if that's the case, then this is a pretty cool little time saver. So normally, I'm sure we're not going to have a time that's quite so funky, but let's give ourselves something that we might actually use. We might actually use a 20-second timer. T # 20S. And just like that, we've got a 20-second timer. And after 20 seconds of an input signal consistently being on here, we're going to energize Q, and whatever's to the right of it is going to energize as well. So that's the real easy way you can put your timer or your delay right there on the same rung as whatever you're energizing. Now, maybe that doesn't make for all the best logic in the world. Maybe you still want to use the digital control logic that's tried and true, where we've got a trigger on one line with the interrupt and the hold in. That's also very elegant, and that's very easy to troubleshoot and very easy to control. But just to show you, you've got some options in this environment. Now, going back here to instruction blocks, I don't need to go through here and show you every single one of these because, there's a description right next to it. You've got the program, you've got the help menu and everything. You can figure out what those are at your own speed. If you need to get that deep into this environment, you can select your control, and once again you can hit F1, or on my computer it's function F1, just depending on how you've got it set up. And look at this. There's actually a really, really good help menu in this software. In fact, that's one thing this software is excellent for. It really gives you a lot of information. So there you go. That is an introduction to ladder logic inside of this environment. There's one more thing I'm going to show you which isn't specific to ladder logic, but it is something that's you're going to need it to do all of these different types of paradigms. How do we know? We're not going to be able to check and see if our programs work, but how can we at least know that our programs are good and that we don't have a bunch of errors in them? Well, right now I've got a simple program and I don't have any errors in it. In fact, if I wanted to, and I just had one a second ago, but if I go ahead and create something, let's just drop a control somewhere on here. So I'm just going to pull in an instruction block, and I'm going to make this some kind of comparator, an equals to. So you see right here I've got these little yellow icons with exclamations telling me, hey, you're missing information. So right away, just looking at this without doing anything, I know I've got some errors. And I could set up tags or values on there, but I'm just going to go ahead and delete that whole rung. And now what I'm left with, I don't see any errors on the screen, but maybe I have one and I'm just not aware. I come up here to Device and I just click Build. And this isn't a fast process because it tries to go through, everything in your project. So it does take a little bit, but at the end, it's going to give you a report down on the bottom, and it's going to tell you, if you look, it says 1 succeeded, 0 failed, 0 up to date, 0 skipped. And right above that on my Micro 850, it says 0 errors, and that's what I'm more interested in. So when I come back in here to my ladder program, those disappeared, but if you look down on the bottom, I've still got my error list, and I can click on that and I can see any errors that I've got in my program. So that's really the last thing that you need to know, and just with that little introduction, I'm sure you could probably program our ladder right now, and that's a good thing because I'm going to let you do that. So next section is going to be me showing you how I wrote the program for my alarms and my analog input signal. But before you go to that lecture, I want you to go ahead and write your own program in CCW ladder logic. So set it up, bring in an analog signal, scale it, have 2 alarms, a high and a low, and then have 2 different bits for each one, a notification and an alarm. And also we want to have an alarm reset and an alarm silence. There are several different ways you can get that done, and it doesn't matter which road you choose as long as you come up with something that you feel will work. Of course, you won't know if it's going to work, but by the end, maybe you didn't figure out how to write a program that actually works in CCW. The world will never know, but you will have become at least a little bit comfortable and familiar with laying down ladder logic in this environment, and that's really the only goal that we can reach at this point without having a Micro 850 or something like that laying on your desk. So give it a whirl, and I'll see you in the next lecture and show you how I approached it.